Hi, and welcome to my channel. My name is Delivered. So today, I wish to take you through Cameroon GCE June 2023, question 4a. And before I dive into this question, I would like to give an advice. As a physics student, before answering any question, the first thing is that you have to always read between the lines because every answer for any physics question lies between the words. Read between the lines. And each of those statements that are made, they are key pointers that points you to the solution to these questions or to the solution to these questions. So let's take this and let's see how we solve it. So the question reads, when a mass of 0.8 kilogram is when a mass 0.8 kilogram is hanging from a helical spring, right? It's hanging from a helical spring. So it's hanging. It's hanging. So if it's hanging, so let's try to highlight. It's hanging from a helical spring. Okay. Now it produces an extension of what? 5.2 centimeters. Take note of that. And the object is then suspended from two such identical springs mentioned below. I've not seen the diagram supposed to be here. I'll draw it. And if the mass then is pulled down through a further distance of 4.2 and allow to oscillate freely in a vertical plane, determine the period of oscillation of the mass. Now, the fact that it said it's allowed to oscillate freely in a vertical plane, this tells us one thing, that it is simple harmonic motion. Because when a motion is oscillating freely or something is vibrating freely in a vertical plane, so we know that it's a simple harmonic motion. Now, we want to calculate the pure oscillation. So to calculate the period of oscillation, so the first step we're going to do is calculating the period. A period of oscillation. That's what we want to calculate. Right now, what's the formula? The formula says is T is equal to 2 pi for simple harmonic motion of a spring and M and K. Now, there are two cases here. You see, the first case, when the mass is hanging from a helical spring. This is a helical spring, and it produces an extension of this. So the first case that we have, it's like this. There's a mass, there's a width, and there's an extension, T. Now, they say this one produces an extension of 5.2 centimeters. Now, they say the second case, if the mass then is pulled, if the mass suspended, if the mass is then suspended from two such identical springs as shown below. So in this other case, we have two springs that combine, and the mass is suspended, the same mass. That's what happened. So you have the two diagrams. So in this first case, it was not oscillating, so it does not perform simple harmonic motion. In this case, this is where they pulled it down and it was now oscillating, performing simple harmonic motion. So this is case 1, and this case 2. So in this case 1 right now, that we are seeing, now here, the simple harmonic motion is not undergoing simple harmonic motion. So by equilibrium conditions, if it's just standing, it means that the tension in the spring is equal to the weight. So it means that C here will be equal to mg. And now in springs, the tension is same as the force, which is same as kx, equals to mg. So k will be equal to mg on x. So from this, we can calculate k to be equal to, the mass was 0.8 kilogram times 9.8 meters per second squared all over 5.2 times 10 to minus 2. You have to make sure the units are consistent. So you have 150.8 Newton per meter. So you have gotten now the constants. Now, the ask now calculate determine the period of oscillation of the mass. Now, should we be calculating the period of oscillation of this system 1 or system 2? We cannot calculate that of system 1 because system 1 is not performing simple harmonic motion. So we have to do that of system 2. And they're saying that this system 2 is undergoing what? Simple harmonic motion, and they are identical springs. Meaning that this formula that we have here is just for a spring, but now we are talking about two springs which are what now are in parallel. And these two springs are in parallel. It means that T, K, the total springs constant equals to K1 plus K2. But since the springs are all the same, it means that K equals to K1 equals to K2, which implies that all of them because of what? 2K. Then our tension equals to T equals to 2 pi, the square root of M over 2K. That will be the formula. Now we know our mass so T will be equal to 2 pi, the square root of the mass is 0.8 kilogram over 2 times 150.8 Newton per meter. All this. Now we are doing all this because we are using the same principle because they said from two such identical means that it's the same. These two springs are the same. And because it's the same, we have the same answer. So I just want you to pause the video, take out your calculator, and try to redo this, what we have just explained, and put your answer. To confirm your right answer with mine, my answer will be in the description section. So thank you as I take the next video on Cameroon GCE June 2023 question 4b. Stay tuned.